we will see about a compound microscope, how the compound microscope works, and how to find the magnification of the image which is formed in a compound microscope. So what is a compound microscope? So it's almost similar to a simple microscope. We already know that a simple microscope is used to view minute objects in an enlarged manner. So similar way, compound microscope is also used like a simple microscope, but only difference is it gives a better magnification. And there in a simple microscope we'll have only one lens, but a compound microscope will have two lenses. So it will have an objective for viewing near the object and eyepiece where we will see, which is the place where we will see the object, enlarged image of the object. So let's see how the let's now see the image formation in a compound microscope. So in a compound microscope, we will have an objective and the eyepiece. So the object which is to be viewed will be placed near the objective. So you can see the small size of it, that is AB. So the height of the object is H. So now the light from the object enters to the objective and an inverted image will be formed at the focal point of the eyepiece. So not of the objective, an inverted image will be formed at the focal point of the eyepiece. Now this inverted image will be acting as the object for the eyepiece, and an virtual and erect and enlarged image will be formed behind the objective. So behind the object. So you can see in the ray diagram. So first the light will enter through the objective from the object, and then the first objective will be at A dash, B dash. So it will be real, inverted and enlarged. And again this will act as the object for the eyepiece. So now again it will work as this eyepiece, again it will work as the simple microscope here. So what happens here, again the virtual, you will get a virtual erect and enlarged image, that is which is at A double dash and B double dash. Now we will find the magnification of the compound microscope. So for finding the magnification of a compound microscope, first we need to find the magnification of the objective and the magnification of the eyepiece. Why? Because we are using two lenses here. So we are going to find what is the magnification of the objective and magnification of the eyepiece. So if you see in a compound microscope, the aperture and the aperture of the eyepiece is larger than the aperture of the objective, and the focal length will also be differing here. So first we will find what is the magnification of the objective, that is MO. So in general, magnification itself, we know it is going to be height of the image to the height of the object. The same thing only here also. So the magnification of the object is nothing but it is equal to height ratio of height of the image to the height of the object, that is H dash by H. So that's what I have written as MO is equal to HI by HO is equal to H dash by H. This is going to be the first equation. So now we are going to find what is the height of the image, that is H dash. So we are going to use the angles here. So I've just we'll take it as a triangle, that is the point where the first image is formed due to the objective, that is A dash B dash. So that angle already it's been marked as beta. So we can find what is tan beta. So tan beta will be equal to the opposite by adjacent. Here the adjacent is going to be the length of the tube, that is from the focal length of the objective to the focal length of the eyepiece. What is the tube length? So tan beta we can write it as the image height is H dash divided by length, capital L. So for small angles we can write beta is equal to H dash by capital L. This is the second equation. Then similar way for finding the height of the object. So height of the object, again where the angle is been formed there. So I have just marked it in red line. You can see almost the height is same. So I didn't mark it. You can just see it. So AB is almost same to the height of the object which is at the optic center of the lens. So I can write tan beta is equal to h by FO. FO is nothing but the focal length of the objective. Again, for small angles we can write beta is equal to h by FO. This is the third equation. Now we're going to compare equation 2 and 3. So when we are going to compare equation 2 and 3, both our RHS are equal. So I can write h dash by L is equal to h by FO. From this we can find what is h dash by h. That is nothing but L by FO. Just by rearranging the terms we will get L by FO. This is equation 4. Now we can substitute this equation 4 in equation 1. So when we substitute, we will get MO will be equal to L by FO. So we have just found only the magnification of the objective. So we need to find the magnification of the eyepiece. So already I have told that when the image is formed, first image is formed due to the objective, that image will be acting as the object for the eyepiece there. So now again the same principle, it is going to act like a simple microscope only. So what happens here, already we have found the magnification in case of simple microscope in both near point and at infinity. So we are going to use that formula itself here. So magnification of the eyepiece, if the image is going to be at the near point, is we'll use the formula which we have already found in simple microscope, that is 1 plus d by Fe. Then magnification of the eyepiece, if the image is at infinity, means already again we have found in simple microscope, that is d by Fe. So the total magnification in case of a compound microscope, it's nothing but product of the magnification of the objective and the magnification of the eyepiece, that is M will be equal to MO into ME. So we can suppose if depends upon where the image is being formed. So if it is going to be, if the image is formed at infinity, means the magnification will be L by, instead of MO we will substitute L by FO, and instead of ME we will substitute D by FE. So by this we can find what is the magnification of a compound microscope. About a simple microscope and compound microscope and their magnification also. So now we are going to learn about telescope. So where is this telescope? Again the same thing. Where is the telescope being used? And then we have two types of telescope and how to find their magnification. So microscope, we all know, it is used for viewing minute objects and enlarged view of a minute objects. What are the uses of telescope? So it's again an optical instrument which is used to see distant objects clearly, like the moon, stars, planets, the other astronomical objects. So telescope is an instrument which is used to see distant objects clearly. So what does it consist of? It's just going to have the two things, that is an objective and an eyepiece. So here I have just given an image or a picture of a telescope. So we'll see the we'll just see the ray diagram, and then we'll see the types of telescope we have. So we are going to see about two types of telescopes, that is reflecting telescope and then refracting telescope. So first we'll see about refracting telescope. So in refracting telescope we will be using lenses, and if you see this ray diagram, it's just opposite of a compound microscope. So we are just going to view any distant objects clearly with the help of a telescope here. So in a refracting telescope, the objective and the focal length the focal length and the aperture of the objective will be larger than the eyepiece. So in a compound microscope, it will be just opposite of it. So now what will happen is, so if you're going to view any object, so first light from the particular object will enter to the objective. Then after it enters, an image will be formed at a second focal point of the objective there. So you can see there A dash, B dash. So that is the image which has been formed due to the objective, and it will be a real image. So after this, what will happen is the eyepiece will magnify this image and it will produce an final inverted image will be produced. So the eyepiece will again magnify the image and it will give us the image of the object here. So this is the working of a refracting telescope. So again we need to find what is the magnification of the refracting telescope. So just look at the angles. So here the angle subtended by the object I have marked it as alpha, and the angle subtended by the image it's going to be. So how to find the magnification? So again the same thing, magnification as we know it's the ratio of the height of the image to the height of the object. So I have to find what is m, that is beta by alpha. So angle subtended by the image is beta and by the object is alpha. So again if I'm going to find for small angles there, beta will be equal to h by Fe and alpha will be equal to h by Fo. So Fo and Fe is nothing but focal length of the objective and the eyepiece. So now if I divide both the things, we'll get h by Fe and h by Fo. So your magnification will be Fo by Fe. And what is going to be the, if I want to find the tube length, total length of the tube here, it is going to be Fe plus Fo here. So this is going to be the magnification in case of a. The next type we have the reflecting telescope, or sometimes it is called as CASSEGRAIN telescope also. So it is just going to be opposite in case of a refracting telescope. So here in reflecting telescope, as we all know, when I say reflecting itself, you should have come to a conclusion that we are going to use only mirrors. So it's just a very simple mechanism. We will be using mirrors in this. So a concave mirror will be used in this reflecting telescope. So we have an eyepiece, an objective mirror and a secondary mirror. So light from the object will fall upon the objective mirror, and what happens? So when light falls upon the mirrors, we know it will get reflected. So it will get reflected and the reflected light will fall upon the secondary mirror. And again the secondary mirror, it's a concave mirror, so again reflection will take place, and this reflected light we can view it through the eyepiece and you can see the images clearly in case of a reflecting telescope. So it's this is the other type of. Why do we use reflecting telescope? So already one telescope is we have seen, that is refracting telescope with the use of lenses, but this reflecting telescope has many advantages over the refracting telescope. So you will not have any chromatic aberration. So we know chromatic is nothing but color. So no color, there won't be any blurred images and all. And in case of reflecting telescope, the images what we get will be more brighter than the images what we see in the refracting telescope. And as the reflecting telescope has only mirrors, it is more cheaper than the refracting telescope. And you have lot other advantages, like you will have high magnification power and high resolving power also you will have in case of a reflecting telescope.